It's not happening. In previous lecture, we began with this module wherein we are talking about a few use cases जहाँ पर linear regression applicable होता है. Then we moved on to few issues related to linear regression data set, as outliers might be there. There might be multi-collinear features. The data might be underfitting, or the model might be underfitting onto the data, or my model might overfit onto the data. Then we try to learn multicollinearity कैसे observe होती है, and then how do we deal with a data which is multicollinear. Then we looked at variance and bias as a concepts, which also instigate underfitted and overfitted models. Then what is our objective? Our objective is to have a system which is neither too highly biased or having more variance. Then we moved on to the concept as linear regression. Technically, our objective is to find this best fitting line. Types of linear regression. Then some terminologies as mean, the coefficients beta 0, beta 1, b0, b1, etc. Some analogies wherein linear relationship can be understood in real world. Some terminologies as dependent, independent features. And then we saw examples of deterministic and stochastic relationships. Now we begin with some mathematical calculations that are the base of this module. So this is my equation, that is the predicted value is b0 plus b1 of x, where b0 and b1 are the coefficients. Least squares method gives us the best estimated line for a set of sample data. तो मैंने क्या बोला कि ये जो data points हैं, I need to find the equation of a line that best fits. अब best fit कैसे निकालेंगे? By the error and then the cumulative error. The error must be minimum. That means the line is fitting best. So how do we compute the error? So for the error, we have three metrics to identify whether the line is good enough or not. First one is called as sum of squared errors. The errors must be less. That is why our objective is to minimize the sum of squared errors. Anyone, why are we taking square of the errors? Why are we not directly calculating the difference between the actual and the predicted value and computing the sum? Yes, Chaitanya or Kalyani. Why is there a need to compute the square of the difference of the error? If you can check this out with this particular example. ये मैंने उस दिन भी explain किया था. Let us say there is one data point here and let us say there is another data point over here. So इधर negative error आएगा, इधर positive error आएगा, and if I only have
difference can
they will nullify
come
each
at
other
zero.
if I only take the sum of the differences. So that is why to have an absolute value or to check the magnitude, we are taking square. And then finally, we will take further in the next metric, we can also take the square root. So this is sum of squared errors, wherein y predicted value will be coming from my equation b0 plus b1x. तो इसको rewrite कर सकते हैं y minus b0 plus b1x. That is same as y minus b0 minus b1x and whole square and summing over it. The second evaluation metric is mean square error. So I am averaging the errors because that will give me a reasonable smaller value. Mean absolute error, instead of just summing out the values and the negative and positive get nullified, I can take the absolute value and then take the average over that. So any of these metrics can be used. Same can be used in Python language as well. अब करना क्या है, बेसिक ऑब्जेक्टिव क्या है, लाइन की इक्वेशन बनाने के लिए आई नीड टू एस्टिमेट दीज कोएफिशिएंट्स b0 and b1. From where will I estimate these coefficients के values? From the data that is given to me. So that is why data science, machine learning is all about being able to make a model that will work well on unseen data. तो यहाँ पे क्या किया है? First we will estimate this B1 coefficient, and from B1 we will estimate the B0 coefficient, and then we will get the line equation. So B1 formula, either you can use this one or this one, both give the same results. कैसे डिसाइड करेंगे कौन सा यूज करना है? तो एट मेनी टाइम्स आई हैव डेटा सेट वेर इन द मीन वैल्यू कम्स एज अ फ्लोटिंग वैल्यू. सो यू अंडरस्टैंड वेल कि फ्लोटिंग वैल्यू का डिफरेंस लोगे तो अगेन एक फ्लोट नंबर आएगा, फिर फ्लोट नंबर को फ्लोट नंबर से मल्टीप्लाई करोगे, सो द डेसिमल प्लेसेस विल बी मोर. इंस्टेड ऑफ using this formula for mean values which are floating, I can directly use this formula. Secondly, ऐसे numbers जहां पर the data is in 3 digits, 4 digits, then again this is not preferable, because then multiplying to 3-digit, 4-digit number will give you a very large value. So it is always preferable to take mean, दोनों का difference, that will reduce down this magnitude, and then it will be easy for calculation purpose. Excel में work कर रहे हैं, code पे work कर रहे हैं, तो irrespective of that कोई भी formula use कर सकते हैं, but manually जब solve करना होता है, then it is preferable to use that formula, which will ease out calculations. So what is this formula talking about? B की value x के साथ आनी है. So I need something as y is equal to mx plus c. This is my slope. So if I check out कैसे याद रखना है इसको? So this is x gets cancelled, this is y and this is x. So this will be y, और ये x इधर आएगा, तो y is equal to bx kind of relationship. That is why in the numerator we have xi minus x mean, yi minus y mean for product summation over, and this is divided by xi minus x mean whole square and then summation over. Or the other formula says product of x and y, sum over this, multiplying with n, and then subtracting summation over x, summation over y for all the samples. And in the denominator we have summation xi square multiplied with n minus summation x the whole square. We'll see numericals on these formulas when some data is given to us. So now how do I compute the value of the other coefficient? So if I put in this, other coefficient value will be y mean average over all the values minus ये coefficient जो यहाँ से value देता है multiplied by x mean, that is average over all the x values. So the fitted regression line that now we will be getting will be y is equal to b0 plus b1x. यहाँ पर मुझे y नहीं पता, x नहीं पता, b0 and b1 are given to me. So if someone gives me a particular value of x, I can compute the corresponding value of y. That will be the predicted value of y. That may not be same or close to the actual value of y. So because we are in online mode, I would expect you people, if possible, try these numericals as well. In the class while I'm conducting, or maybe practice it later. तो यहाँ पर क्या दिया हुआ है? X and Y are given to you. And what is being asked is, this is a sample of observed height and corresponding weight. You have to create a relationship model. Model linear regression का क्या बोलेगा? I have to find the coefficients from the model, from the data, and establish the mathematical equation y is equal to b0 plus b1x. तो b0, b1 इस data से आएंगे. Then we will compute average prediction error, which is termed as residual. So this error is to be minimized. तो सबसे पहले हम क्या करेंगे? We will use these formulas. Summation over yi. So I can sum over this. I do not know b0. I do not know b1. I can sum over this. Put in the values in these two equations. This is the formula for residual. Residual is same as sum of squared errors. So this is my y, this is my y cap, दोनों का difference का square is termed as residual. जब भी किसी चीज को maximize या minimize करना होता है, that is our objective function. What we do is we take the partial derivative and equate that partial derivative to 0 so that I can get किस particular value के लिए minimum and maximum मिलेगा. That is what is being done over here is, this is q. I compute del q by del b0, del q by del b1. So इसका जब partial derivative लेंगे with respect to this coefficient, so this 2 comes over here, और इस कोएफिशिएंट का माइनस विल कम आउटसाइड, सो दैट इज व्हाट इज रिटन हियर. इसका जब पार्शियल डेरिवेटिव लेंगे विद रिस्पेक्ट टू बीटा 1, so this again 2 will come here, minus will come here, and also x will come over here because x को वो constant ले रहे हैं, that data is given to us, and b1 is unknown, that is a variable. इन दोनों इक्वेशंस को जब हम सॉल्व करते हैं तो then we get the same equations जो पिछली स्लाइड में लिखी थी. So this is a derivation how these equations are coming from. So when you solve these two, these set of statements will be formed. ये -2 चला जाएगा, समेशन डिस्ट्रीब्यूट हो जाएगा. b0 पे जब समेशन लेंगे इट विल बी -nb0 because there are n terms. Similarly, x and y will be in product. This is neglected. This comes into product. So b0 is a constant, it comes outside. This is summation. Similarly, xi or xi will become xi square. When I solve these two for two unknowns, क्या unknowns हैं? b1 and b0. I get these two equations. ठीक है इतना? So the same value was there in the previous slide. This is just 1 minute. Sorry. Hello? Okay, sorry. So now what we do is, ये जो residual की बात कर रहे थे, that is an error and that is this represented. Always you have to remember that this residual will not be perpendicular to this line. It will be parallel to y-axis. I have already told you the reason behind this. क्योंकि एक particular value x की उसके लिए actual value y की और ये predicted value y की, तो y की predicted value and actual value का difference is your residual or the error. Then this partial derivative that we were talking about, that is calculated using gradient descent method. So I don't know whether you people have checked this out earlier. This is something like I have a huge bowl and I drop a ball, और इस ball को अगर बहुत fast we will drop down, so maybe I lose this point which is a minima. If I drop this ball very slowly, then I might take a lot of time to reach the minimum. So that is why we have this gradient descent method, which has so you were seeing this. This is gradient descent method, which is required to minimize the cost function. जो पिछली slide में cost function था, residual का जो cost function Q था. ये method क्या बोलता है? हम कहीं पर भी, whether it is neural network, whether it is logistic regression, linear regression, ये coefficients को randomly initialize करते हैं. Slowly we iterate and try to find an optimal value of these coefficients. So we have randomly initialized. Now what we have to do is we are computing the partial derivatives. जैसा पिछली slide में देखा. This will give me an updated value of these coefficients. We go on doing this, these steps until and unless these coefficients converge. तो इसी convergence के लिए I was telling you, you can see this learning rate alpha over here. इसकी वैल्यू अगर बहुत लार्ज है तो कन्वर्जेंस बहुत फास्ट होगा एंड दिस कन्वर्जेंस माइट मिस द ऑप्टिमल वैल्यू of the minimum error. If this alpha is too small, this will take a lot of time. So this will take a lot of time to converge because we are working on huge data sets. So we should have an optimal value of alpha should neither be too small nor too large. So in case of linear regression, how this gradient descent is applicable? This is my line of linear regression B0 plus B1x. थीटा हम बोलते हैं न्यूरल नेटवर्क के कॉन्सेप्ट में, लॉजिस्टिक रिग्रेशन के कॉन्सेप्ट में. सो एन एनालॉगी हैज बीन पुट ओवर हियर. यही हमारी y कैप की वैल्यू थी. दैट इज आवर हाइपोथेसिस. हाइपोथेसिस क्या होता है? एक assumption होता है. तो वी आर assuming that by forming this model, by forming this linear regression की line, I should be able to make predictions. That is why we are calling this as hypothesis. Cost function or the objective function is a function that is required to be minimized. यहाँ पर cost function हमारा क्या है? Loss function. Loss function क्या है? The difference in y cap and y की value. So this is my y cap, this is my y. How are the representations happening? ऊपर जो I superscript लिखा हुआ है, that indicates iterations. So you must be knowing neural networks multiple iterations पे run करते हैं and then they converge. Convergence का मतलब performance increase होती जाती है. After certain time performance starts decreasing. That means this is the best possible value. Or after this iteration I need not do training, otherwise the model will learn the data. It will not generalize well. Then we are averaging out by m so that m in the denominator gets cancelled. We are writing 2m here because जब हम डेरिवेटिव लेते हैं तो यहाँ पर एक 2 आता है जो पिछली स्लाइड में देखा. Both of them should get cancelled for just making a simple equation that should not having that redundant 2. So we are trying to say that gradient descent is required to minimize cost function for linear regression model. So the same equations and same calculations have been shown here. ये मेरा parameter, इस parameter की optimal value I need to find. So for this I am performing partial derivative. Partial derivative किसका? ये equation जो है h theta minus yi. H theta is my theta 0 plus theta 1x, that is written over here. When I take partial derivative of this with respect to theta 0, then these calculations are there, and with respect to theta 1 these calculations are there जो पिछली स्लाइड में की. जब theta 0 के रिस्पेक्ट में कैलकुलेशन किया तो यहाँ पर 2 आया, ये 2 कैंसिल हो गया, ये 1 by m बचा एंड ये एज इट इज रहेगा. जब theta 1 के रिस्पेक्ट में कैलकुलेशन किया, so because theta 1 has this x term, so this x term will come outside. 2 gets cancelled. ये वाला 2 जब इधर आता है, that is why there is no 2 over here in the denominator, and I can rewrite this thing as the hypothesis. So this is a simplified version of when we are trying to find parameter updates for theta 0 and theta 1. Now, I have created my model. I had the data. I have tried to find the value of B0 and B1. Now, how do I check that how good my model is? So to check that, we have a parameter as Pearson coefficient, that is a strength of linear association. किसके किसके बीच में? ये okay, this question I'll ask you people. The strength of linear association must be good between independent variables or between independent and dependent variable. Two independent variables must be correlated highly, or one independent and one dependent variable must be highly correlated. दोनों सुन ही नहीं रहे क्या? खाली लिंक ज्वाइन किया हुआ है? Okay, I'll simplify this question. Let us say I am predicting my performance on the basis of my height and my weight. So my height and my weight should be highly correlated, or as per my height, my performance should be highly correlated, or as per my weight, my performance should be highly correlated. So high correlation, as you can see in the formula, is not between x1 and x2, it is between x and y. So independent and dependent features must be highly correlated, and among the features, correlation should not be there. If it is there, then I need to perform dimensionality reduction technique to reduce correlation. As I must have explained the other day also, अगर मेरे पास features है height and weight and BMI, so I should drop one of the feature because all of these three are highly correlated. My next question is, any data visualization technique that helps you identify that the features are correlated? Any graph you plot? सुनना ही नहीं है तो इससे अच्छा तो I'll record my lectures and then post on GCR, then people can listen to that. और अगर उतनी भी नीड नहीं है तो you can study on your own. I have so many pending works. I'll start doing that. Okay.
No, ma'am, it's not like that.
Okay. So then you might not be knowing the answer, but I'll tell you the answer. So my question was that this correlation must be there high between independent variable and dependent variable. Why? Because हमारा objective क्या है कि final जो predictions है that should be coming from my features. मैंने जो data collect किया हुआ है वो features जो है उस for example I have heart disease or not, that should come from the data which I have collected from diagnostic centers. लेकिन दो डायग्नोस्टिक सेट टेस्ट जो है उनका डेटा आपस में कोरिलेटेड नहीं होना चाहिए, और अगर ऐसा है then there is no sense of doing those independent tests because one data is giving me something similar to the other data. So that is why among the features correlation should not be there. So over here what we have to put is, ये मेरी B1 की इक्वेशन थी जो हमने पिछले साइड में देखी, फिर हमने B0 निकाला था, उससे हमको क्या मिलेगा, लाइन की इक्वेशन मिलेगी. सो दिस इज अगेन द सेम डेटा विच वाज देयर इन द प्रीवियस स्लाइड, हाइट और वेट का. ये मैंने एक्सेल पे पूरा कैलकुलेट किया है. आई विल एक्सप्लेन यू व्हाट इट इज. I'll compute the mean value of height. This is x mean that is coming out as this. Compute all y ka mean that is coming out as this. I compute x minus x mean, the corresponding values are listed here. Y minus y mean, the corresponding values are listed here. अभी इस फॉर्मूले में क्या चाहिए, x minus x mean, y minus y mean and x minus x mean का स्क्वायर. तो ये दोनों का प्रोडक्ट ये न्यूमरेटर में आ गया, ये दोनों का प्रोडक्ट ये डिनोमिनेटर में आ गया. When I divide these two together, what will I get? Which variable की value will I get? If I divide this fifth
B1.
column, yes.
B1.
Kalyani, come again.
B1. B1.
B1 राइट. B1 की वैल्यू मिल गई. अब इस B1 की वैल्यू को जब हम यहाँ पे डालेंगे, y mean x mean multiplied with B1 and subtraction, I'll get B0. So this is my B1 and this is my B0. अब क्या करना है, ये पहला पार्ट हो गया which will give me the equation of the line, that is coming out as y is equal to 0.67 x minus 38.45. Now I need to check how much good this line is. मतलब x और y में कितना ज्यादा correlation आ रहा है. So one part of the question that you people get is you are given some data, you have to compute the coefficients, you have to compute the equation of the line, and एक question दिया होगा कि एक particular x की value पे y कितना आएगा. So when I put this value of 70 in that line equation, I'll get a corresponding value of y. Second part of the question says, what is the how much is a line clearly associating x with y. So in this formula, what is required is xy is required. So we did the product of x and y. Then we are doing sum over x. Sum over x is this. Sum over y is this. Product of these two is written over here. Sum of x and sum of y. Sum of xy is written over here. Sum of x square is written here. Sum of y square is written here. Sum of x is written here. उसका square लेना है. Sum of y is written over here. इसका square लेना है. And when I put in all of these values here, I get the corresponding value of r as 0.977. हमने दिया जी. नहीं ठीक है मैडम. So if R value is coming as 0.97, it is a good sign that my X is correlated to Y or Y is correlated to X. So R value lies between -1 and 1, both inclusive. R value -1 means again there is correlation but in negative direction. मतलब कि Y जब increase करेगा, X decrease करेगा, but they are correlated. This gives me a signal that it is a good model. Similarly, R की value अगर 1 आ रही है, that means when X will increase and Y will increase. कौन सा मॉडल अच्छा नहीं होगा जिसकी वैल्यूज आर लाइंग समथिंग नियर टू जीरो आइदर इन पॉजिटिव और इन नेगेटिव. So this is one question that you people will get. And then checking the performance of model is one thing and evaluating the model is another thing. So for evaluating the model, there is a metric as R square, capital R square. So for that, what we should know is ये मेरा linear regression की line and this is my mean prediction. Mean means for any particular value of x, I am getting this value, a single value, that is pi mean. मीन कहां से आएगा? जो भी एक्चुअल वैल्यूज प्लॉटेड थी उनका एवरेज. तो सम ऑफ स्क्वायर टोटल सेज माय एक्चुअल वैल्यूज हाउ मच दे आर डिफरेंट फ्रॉम द मीन, उसका स्क्वायर एंड सम ओवर. अगेन व्हाई आर वी डूइंग दिस? सो दैट दे डू नॉट नलिफाई. तो दिस इज डिस्पर्जन ऑफ ऑब्जर्व्ड वेरिएबल अराउंड मीन. Second metric is SSR, that says sum of squares regression. Regression मतलब जब हमने prediction किया उसके basis पे कितना error आ रहा है. So that is, if you look here, जो difference था वो actual data points से था. यहाँ पे जो difference है वो plotted line के data points पे. For example, for this corresponding value of x, this was my actual y, but my predicted y is lying on this line. तो इस line पे जो value है वो mean से कितना different है? Y cap, that is a predicted value, minus y mean square and then sum. The third one says sum of squared errors. So this is an unexplained variation, the difference between these two. That is inherent in the model. I cannot do anything. That is because of my data that is not good enough. So SST is SSR plus SSE. So my Y actual value, how is it different from the mean? It is equal to Y predicted value different from the mean, iska error plus an unexplained variation in the data. So the total variability is equal to the variability explained and the variability which is unexplained, that is error. So what is to be done is, this will help us find out the value of capital R square, that is called as coefficient of determination. That identifies how good your line is. Your SSE value, sum of squared errors, must lie between 0 and SST. So R square की value is sum of squared total minus sum of squared error divided by total sum of squares. This is also equal to SSR from the previous slide. So this is 1 minus SSE by SST. Thus, my R square value must lie between 0 and 1, both inclusive. So again, a model that is having R square value equal to 1 is a very good model, and having a value equal to 0 is not at all a good model. So capital R square theoretically is proportionate reduction of total variability in Y associated with use of independent variable X. So I'll explain you this. ऐसा नहीं होना चाहिए कि एक पर्टिकुलर x की वैल्यू के लिए देयर इज अ लॉट ऑफ वेरिएशन कमिंग एट ईच रन ऑफ योर आउटपुट. बहुत वेरिएंस नहीं होना चाहिए आउटपुट में. इसी वेरिएंस को जो मॉडल रिड्यूस कर पा रहा है दैट इज अ गुड मॉडल. सो कितना रिड्यूस कर पा रहा है, दैट इज द वैल्यू ऑफ आर स्क्वायर. Larger is the R square, more is the total variation reduced by including the variable X. So this will help me decide कि वो feature को हमको लेना है prediction के लिए कि नहीं लेना है. Many times I have so many features in my data, those particular features may not be important in the model. So this helps us remove irrelevant features from the model. Is this clear? Again, it will be
Yes.
better when you look at these formulas, do numericals. So again, if I check out further on this, अगर एसएससी की वैल्यू 0 है, सो लेट अस से क्या मतलब है एसएससी की वैल्यू 0 का? एसएससी 0 है, एनीवन कैन मेक इन्फरेंस फॉर दैट? रियल वर्ल्ड डेटा में ऐसा नहीं होता है. दिस इज अ वेरी गुड मॉडल wherein unexplained variability, unexplained error is not there in the model. तो जब SSC की वैल्यू 0 है, आर स्क्वायर हो गया 1. दैट इज माई बेस्ट मॉडल, अ वेरी rational model. If the slope of the line is 0, slope अगर 0 है, that means कैसी line बनेगी? That will be a line falling on the mean. So if a line is falling on the mean, तो ये error जो है y cap minus y mean वाला वो 0 हो जाएगा. y cap minus y mean वाला error मतलब SSR. सो जब SSR 0 हो जाएगा तो SSE विल बी इक्वल टू SST. SSE जब SST के इक्वल हो जाएगा, दैट मीन्स this difference will be 0. So my R square will be 0. That will be a very bad model. Why will it be a bad model? क्योंकि मैंने क्या बोला, ये जो line है, this is lying around mean. For any value of x, you're getting same value of y. This is a good model or a bad model? For any value of x, if you get the same value of y, yes, Kalyani?
Bad model.
It is a very bad model, and that is why capital R square value is coming out as 0. The closer R square is to 1, greater it is said to be the degree of linear association between x and y. Then there is a third term called as coefficient of correlation. So the relationship between small r and capital R square is small r is square root of capital R square. Small r कौन सा? वही Pearson correlation का small r. These two can be related together. So whenever both the questions are asked, you can compute capital R square, take the square root, and then it will return you two values, one positive and one negative, for coefficient of correlation. So again, on the same data, we have computed capital R square. कैसे compute किया? हमको height दिया हुआ था, weight दिया हुआ था, और जब हमने B1, B0 निकाल लिया, line की equation आ गई. So when I'll put these height corresponding values in that line equation, I'll get the corresponding predicted value. So actual value weight की 63 है for height 151, predicted value 63.41. ठीक है? Now I know these formulas SSE, SST and SSR. SSE किस में आएगा? Y मतलब weight और Y predicted मतलब ये value, इन दोनों का difference. SST will be Y का mean. Y का mean निकाला और actual value of Y, how is it differing from the mean values that is written and it is being squared. Third thing is the predicted value of Y, how much it is differing from the mean value. दोनों का difference of a square. Sum over these and then putting in the formula of R square. R square क्या formula बोल रहा था? SSR divided by SST. So when I take this divided by this, I get the value as 0.95. So is this a good model or a bad model? If I'm getting capital R square value as 0.95, is the model good or bad?
Good.
It is pretty good as the value is nearer to 1. So this is just an example for you to practice wherein X and Y values are given to you. Where X is weekly advertising expenditure and Y is weekly sales. तो क्या करेंगे इसमें से? हमको n पता चल रहा है, समेशन x करेंगे, समेशन y, समेशन x square, समेशन x by y, because I need to put in all of these values in this formula to compute b1. यहाँ पर हम वो मीन वाला कॉन्सेप्ट क्यों नहीं कर रहे हैं? बिकॉज y की वैल्यू 4 डिजिट में, तो फिर प्रोडक्ट लेंगे तो बहुत बड़े बड़े कैलकुलेशंस होंगे. Similarly, I can find the value of b0. From here, I'll get the equation of line. And let us say I need to find for a particular value of expenditure. तो इससे क्या मीनिंग निकल रहा है? That if weekly advertising expenditure को $1 से बढ़ाया तो sales $10.8 से बढ़ेगी. Second thing, I can compute कि अगर advertising expenditure $50 है तो estimated sales कितनी आएगी? That is a predicted value of sales. I can compute. So this is called as point estimate या forecast of mean response या sales. तो mean value पे कितना estimate आ रहा है? This can be computed. So till here, is it clear?
Yes, ma'am.
Then comes a concept of residual. रेजिडुअल स्टार्टिंग से बोल रहे हैं इट इज एरर. अगर हम सारे एरर्स को प्लॉट करें दैट इज कॉल्ड एज रेजिडुअल प्लॉट. Again, many inferences can be drawn by reading the residual plot. This plot is not giving us much inference because it is not following any systematic pattern. So no individual observations or systematic changes are happening in the error as x value is increasing. Residual plots are scatter plots. They plot residuals against fitted values, against the predicted values. They are against the independent variable, and they are plotted over time if the data is chronological. As you can see, it is in days. So over the days, the data has been plotted. So there are two residual plots given here, and let us say how do we analyze them. In this particular plot, the residual plot is a curve pattern. So a straight line, if I want to fit along this, it is not a good prediction. And there is a pattern being followed. In this particular residual plot, I can see a pattern as more spread is there for larger values of x. So prediction come accurate hoga when x is large. So I should choose a smaller value of x for my data. So such kind of inferences can be drawn by plotting residual plots. So this is again an example for you people to practice. Jahan par these three parameters are given. And what is to be done is, many factors affect the wages of workers, the industry they work in, their type of job, their education, experience, changes in general levels of wages. So these are samples of 59 married women who hold customer service jobs in Indiana banks. Over here, we have the weekly wages, length of service, and the size of the workplace, whether it is large, whether it is small, depending on how many workers are working. Because industry, job type, and time of measurement are same for all 59 subjects, तो इनको हमने हटा दिया है. So we want to check relationship between wages and length of service. So again, we can have a plot in length of service and weekly wages, and then we can check out and try to fit a model and then check out the error is particular lines, because there can be other lines also. I need to find the best fitting line. So when I need to find the best fitting line, I'll first find out B1 and B0 from the formulas that we have discussed earlier. I'll find out SSC, SST, SSR जिससे कि R square आएगा. तो अगर इस particular line जो हमने बनाई है from B1, B0, R square value is coming nearer to 1 as it is coming 0.79 over here. So I can say this is a good enough model. Not very good, but good enough. तो यहाँ से पहले हमने B1 निकाला, फिर B0 निकाला. We can make predictions for, let us say, input LOS is 125. So the predicted value of expenditure will be $423 per week. Similarly, I can compute these three values, wherein SST is coming as 0 because all observations are same. अगर ऐसा हुआ तो SST 0 means all observations are same. Over here, the SST value is this. I compute the difference, compute SSR, take the numerator denominator, compute R square. So that means we are getting a good enough model. This is another example. Okay, I end over here because we have completed with simple linear regression. We have completed with correlation. We have completed with evaluation of the model using R square. If you have any doubts still here, you can ask in the next session. I'll upload the PPTs on the classroom. Okay.